So in this video, we're going to take a look at the three exponent laws, also known as the index laws, and see where they come from and how perhaps we can use them. So the first thing I want to understand is about what an exponent means. So if I have something like 2 with a 3 there on top, okay, that 3 is known as the index or the exponent, and it means how many times I multiply 2 by itself. So 2 cubed means 2 times 2 times 2. Of course, that's 8, but we don't need to write that down for this example. So if I wanted to do 2 cubed multiplied by 2 to the power of 4, for example, then what I've really got here is 2 times 2 times 2. Well, there's my 2 cubed, multiplied by 2 times 2 times 2 times 2. There's my 2 to the 4. So of course, when I'm multiplying, these brackets don't really make a difference. So let's get rid of them. So of course, what I've really got here is I've got 7 2's there. So that is going to be 2 to the 7. And clearly you can see that I just had to count up these 2's and these 2's and add them together. So it's the 3 and the 4 added together that's making the 7. So this is known as the first of the exponent laws. And in general, we can use x's. If I have x to the power of a multiplied by x to the power of b, it's going to be x to the power of a plus b. We add those things together. We've got to be careful that the 2, the base, is the same, okay? Or the x's are the same. So, for example, I can't do 3 squared times 4 cubed and use this rule. It won't work because I have different bases. The bases must be the same. So there's our first law, and we have written it up here, look, in a nice, easy to understand format. We add the powers when we multiply two numbers of the same base. Now, let's look at the second law and see if we can figure out where that one's coming from. So this is the law of division. So what about if I had, let's use x's and have an algebraic example this time. X to the power of 4 divided by x to the power of 2. Well, I could write this in kind of fractional notation. I could write x to the 4 as x times x times x times x, because it's how many times I multiply x by itself. And I'm going to divide that by x times x, which is x squared. Now, clearly, you can see common factors on the top and the bottom of this fraction, on the numerator and the denominator. So, of course, I can cancel them. Anything divided by itself is just 1. It just cancels out. So those are going to cancel out, and those are going to cancel out. So this is clearly going to be x squared. And, of course, what's happened here is I counted up these amount of x there, which is the 4, and I took away the 2 on the denominator, which is that 2 there. So it's going to be a subtraction in this case. So in general, what we can say is if I have this division going on here, I'm going to get those two exponents and do the first one, take away the second one there. All right? Okay, now, final example. Okay, let's look at the third law of indices right now, or exponents. So in this rule, okay, we have powers of powers. So let's imagine a 2 again. I like 2's. 2 cubed to the power of 4. What would that be? Well, to the power of 4 means that expression or number multiplied by itself 4 times. So this is like doing 2 cubed times 2 cubed times 2 cubed times 2 cubed. Now, of course, we already know from the first law that if we are timesing different numbers with the same base, we can add those exponents. So this is going to be 2 to the power of 3 plus 3 plus 3 plus 3. So, of course, it's 2 to the power of 12. And what's happened here, of course, to get that 12, that shortcut you should have already spotted, is these two numbers are multiplying together to make that 12. So if we have a power of a power, then they multiply together to make an exponent. Here it is written again. A to the m to the power of n, you times those two exponents together. A to the power of m times n. Okay, I hope that gives you some understanding of where these index laws come from. Let's just do one little extra thing before we finish this. Okay, so let's just have a quick look at some pattern spotting now. So we already know from a previous example what 2 to the power of 4 is. It's 2 times 2 times 2 times 2. You already know what 2 to the 3 is. So you should know what 2 squared is. It's just 2 times 2. Now, those are all very obvious. We've already explained the 4, the exponent, or the 3, or the 2. That's the number of times we multiply 2 by itself. So let's just carry on this thing here. Well, what would 2 to the 1 be then? Well, it just means 2. So anything to the power of 1 is just itself. But we can go further because we can also consider 2 to the power of 0. Now, we want to think and look at the patterns here. So let's just think about this. Well, clearly, if I followed from the top down, I can cancel out a 2 by dividing by 2 to get from 2 to the 4 to 2 to the 3. 16 divided by 2 is 8. 2 to the 4 divided by 2 is 2 to the 3. And of course, we can keep dividing by 2s to keep moving down. So logically, the next thing to do is to divide by another 2. And 2 divided by 2 is 1. This pattern works whatever the base. So anything to the power of 0 is always going to be 1. Now, let's just have a look at some nice, silly examples to help us understand. Okay, so all I mean by this is just remember it. 3 to the 0 is 1. 4 to the 0 is 1. So this sum here is just 1 plus 1. It's going to be 2. 6 to the 0 is 1. 7 to the 0 is 1. This is just 1. It's the same every single time. I'm just doing this to help you remember that anything to the power of 0, whatever the base, is always going to be 1, because it just means that number divided by itself, which is 1. Again, 8 to the 0 minus 3 to the 0. 1 minus 1 is 0. And in this example here, look, we've got 1 plus 1 minus 1. It's just going to be 1. Okay, hopefully that's helped you to understand some exponent laws and that anything to the power of 0 is always